So we were there. What we have done till now is, just as a quick recap so that the context can be set, we have understood what is big data in Hadoop. We have understood the architecture of Hadoop, HDFS. We have gone through the MapReduce to see what is a mapper, what is a driver, what is a combiner. Of course, more about combiner and partitioner we will be doing it today. This is where I had a roadblock last Sunday. Okay, and then we have already done PIG. We have finished off with HIVE. So today my plan is to finish off with MapReduce, and if time permits, start with your advanced HIVE. Okay, and then continue on in the same fashion for the rest of the sessions. So that is what my plan is. So without any further delay, let's move on. So we had gone through the objectives of this module. We will talk about the different counters. So I hope you have downloaded the necessary documents. Let me open up another window so that I can show you the necessary stuff. Let me go down to my customers. Let me go down to my Edureka. 10-week schedule. There should be something called as Advanced MapReduce codes, which is available for you in your LMS, and I'm just opening it up locally so that it would be fast. So these are the 7 examples that we are going to see today. I hope you have gone through these things, especially our non-Java guys, so that it would be comfortable for all of you. We had seen, we had stopped at the joins when we had a, great Andish. We had stopped at the joins. So revision is something that we have already done, so I'm simply going to skip these slides. We had understood what is different joins, and we have understood, Annie had asked some questions. We have answered all of these things. Okay, so this is where we have to start with today. So when we talk about joins, there are 2 types of joins. This is explained in a much more detailed way in case if you wanted to go dive deep into it. Of course, we will have some examples. So the blog that we have, MapSat join versus join by Edureka, please have a look at that blog in case if you haven't done that already. If you're having a big table and if you wanted to join with a small table, you can do something called as a map side join. There is also a reduce side join also. So we will have a look at both of those examples. So here what are we trying to say is there is a map task. A task, is something that is going to be running on individual block in one node. So there are multiple splits. And there is a small table which I wanted to be there on the node locally available so that it can be joined at the map side. That's what you'll see it in the next slide. See here? So you have got a task. When the task runs locally, I would want the small table to be available for me so that the individual mapper can look at that small table and you'll be able to join. This is what is called as distributed cache, and we are going to see an example of this distributed cache over here. Like I said, I'll be walking through the code and I'll be giving you the complete understanding about what it is, but I would want you to go ahead and actually execute all of these things, because unless you get a feel of how to run it, just by me running it and showing it is not going to be of any significance, because I know how it works. I would want you to actually try the hands-on, especially in Advanced MapReduce. A lot of hands-on is what is required. Okay, so let's continue. So this is where I had stopped last time, how to do joins in MapReduce. So let me go back to the folder structure again. And if you look at the join, there is in your LMS in Advanced MapReduce, there would be a folder called as join program. And what we have done over here is I have got 2 data sets. So join would mean, of course, I need 2 data sets. So there is a customer data set, there is a transaction data set. Let me show you the schema of the customer data set. Let me go down to my transaction and just one sec. Let me go down to my transaction and try to open that in the editor called as Edit Plus. There we go. So let me decrease the font of it, because I wanted to show the whole row. So let me make it as 14 and I'm sure it would work. There we go. So what I have over here is I have got 9 records. I'm sure you would have seen this transaction data set in the HIVE example also. Okay, HIVE and Pig also, you have done the customer data set. So what do we have here? We have got a transaction ID, we have got a date, we have got a customer ID, we have got an amount, we have got the primary product, the secondary product, the state, the city, the state, and whether the transaction was cash or credit. And just for the purpose of simplicity, we have kept over here limited amount of rows, about 60 rows is what we have kept over here. Then we have got another file that is called as customers. You know that there is 9,999 records, but again for the purpose of simplicity, we just have got 10 records over here. And you can see here the thing that is common in both of them is going to be your customer ID. Okay, so now let's go back and understand what is this join program all about. So we have got a Word document that we have kept in the LMS itself, which will explain to you what is the purpose of your join. Great. Vinith was asking, what are the maximum size of the file a distributed cache can handle? I mean, how small is small? Okay, Vinith, whatever can be put into the memory of the node, that is what is the size of it. Okay, so there are two ways of putting it. Either you can put it in the configuration, or if you look at the distributed cache, if the individual node has got a memory of 4 gigs, theoretically you can put in a file of 4 gigs into the memory, but then you can put in a file bigger than that also, but then paging would happen in that case and performance would be impacted. So that is what is the context, Vinith. I hope that makes sense. So now coming back to this. So a common situation in organizations is that transaction records are typically kept from the customer records because we are talking about 3NF, third normal form. Of course, there is a relationship between the two. Usually the transaction record contains the ID of the customer who had done the sale. So in Hadoop world, this will be represented by two types of data files, one containing the records of the customer ID, that is the CUSTS file for us, and other containing the full data for the customer. That is, the first one is the TXNS file and the second one is the CUSTS file. Now, whenever you want to do any analysis, you would want to join the data. So let's say you have got a hypothetical use case. You want to find out the total number of transactions and the value of a customer, but I don't want it with the help of an ID. I want it with a name, so that if somebody wants to give a call to the customer via the service representatives, they will have the name of the customer and the details of the transaction. Okay, so that is what is the use case that we have over here. So we can perform the above report by using a reduce side join. So let's see an example of how that happens. So let me go back to the actual example. So I'm going to open up reduce join example. So there we go. So what are we doing over here? We have got two separate data sets. Okay, we have got a customer CUSTS file and we have got a TXNS file. So obviously I would need two separate mappers, right friends? Because the data that I want to pick up from both of them are going to be different. Okay, but what will I ensure is that the key that is going to be coming out of the mapper would be common across both the data sets, so that the shuffler will ensure that all the values of the key, same key, which is the common key. Like in RDBMS, if you want to do a join, you need something common in both the tables, right? So the customer ID key is what is going to be the common key. So what we're going to do is we will have a key and a value. The customer ID is always going to be the key in both the data sets, so that the shuffler will ensure that all the values of the same key go to the same reducer, and then we will do some analysis. Because what do we want? We want to find out the number of items that a individual user has bought and the total sum of the transaction. Okay. So first we are going to have a cust mapper, that is a customer mapper, and as you would know, this is you will have a map function. Okay, and what we will get in the record is the whole customer record. And what is the values that we have in the customer record? Let me go back to the file, data file. You have got 0, 1, 2, 3, 4. I'm interested in the 0th column, and I'm interested in the first name, right? So in the first column. So these are the two values that I would want to pick it up in my mapper. So you would see over here that first I get the whole record, then I convert that into, I split it up based on comma so that I convert that into an array. And see, what am I printing? I'm printing out the ID. Okay, that is, I'm picking up the customer ID and I am picking up the customer name. You will also see that I am having something over here. The value is a composite value. Until now you have used a single value. I'm using a composite value over here so that whenever it goes through the reducer, okay, after the shuffler, I have to understand that this is what is for the customer. So because for the same customer ID, both the values from the customer and transactions file will come. So I need to know from where the data is coming, right? So I'm having a composite value. The composite value would contain, there's something called as cust I have kept. You can keep any identifier, okay, separated by a tab, okay, and I have got the name. So what is going to be written out of this file is going to be the customer ID and the customer name. That is what I'm doing in my mapper for my customers. Let me go back to my question. Somebody had a question over here. Hey Praveen, I could have used long writable. So I fully agree with you. This is just to show you that you can put in any type. Okay, object is a base class of everything, right? So I can put in any type, but ideally you can always use long writable. That is what Praveen had asked. He was concerned that why are we using long writable over here? Okay, cool. Then I will go down to my transaction file. So let me open up my transaction file. So what am I interested over here in the transaction file, friends? I'm interested in the 0, 1, and 2. Okay, the customer ID. I'm interested in the amount. Okay, because I'm interested in the amount. Plus, I could have got any of the other things also. But then in the current example, I'm just interested in 0, 1, 2, and 3. Okay, the customer ID and the amount. So let's go back to the example and we will see over here. So in the transaction file, like I did last time, I have split it up based on the value, and see over here how I have picked up the customer ID. So the key is going to be the ID, and what am I interested in? I'm interested in the amount. Of course, I could have got more attributes also over here if I want, but then right now I'm only interested in the amount. Because what is my objective? The customer name, the total number of transactions, and the sum of transactions is what I'm interested in. So you will pick up the customer ID and the amount. And see again over here I have got a composite value, because for the same customer ID that is coming from both the mappers, it will go down to the same reducer. So how do I identify what is a name and what is an amount? So that is the reason I am having a composite ID over here. I hope that makes it very clear, guys. Let me go back to the questions again. Vijay was saying, can we use system.out.println inside the map and loop up the values? System.out.println will only help me in understanding what is the values that is coming. That is all, right, Vijay? Dheeraj was asking, how will we identify ID is from which file? Fantastic. So see over here, the ID is the thing that is the join key over here. So what you should be interested in is what is coming along with the ID. In the customer file, the name is coming along with the ID. In the transaction file, the amount is coming along with the ID. And that is the reason why in the value I have mentioned something over here, so that you'll know that the value comes from which file. Make sense, Dheeraj? Very good. So Manish said, where are we specifying the customer and the transaction file names here? Manish, that will be done at the time when we run the file, right, my dear? That will be there in the driver code. We are only looking at the mapper right now, Manish. Good. So Vijay was asking, where will the output be printed? We have already done that, right? So the output would be printed in the logs directory. Okay, so there are, if you look at your job tracker, okay, it will be there in the job tracker. Sorry, if you look at the job details, that means in our example, the page where the job details are there. that is a job tracker history, job history report, and if you click over there, all outputs are shown. So the outputs are shown in two places, Vijay, since you have asked that question. One, it will be there in the, for every job would have an ID. If you look at the job, you can get based on the job ID. Second, it will also be there in your Linux system, where you will have the job ID also mentioned in your user logs inside your Hadoop. Okay? Cool. Fantastic, Vijay, and I hope, Dheeraj, you're also clear. So now I have picked up the necessary values. Now what will the framework do? Since the ID is going to be common across both the customers and your transactions, all the values of the similar ID will go down to one reducer. Okay, so that's what we are seeing, the reduce join reducer. So let's go back and see what we're doing over here. First, I am creating a variable where I can store the name of the customer. I am having another variable wherein I will keep the total of the customer, and another variable wherein I will keep the count of the customer, because our count of the items, because I'm interested in the number of items, the name, and the sum of transactions, right? Now, what will happen for the same customer? Okay, both the number of transactions that he has made will come down, and as well as his name will come down. So what do I first do? I break up the value, because there would be a /t that would be a separator, right? So a tab would be a separator. So I will break up the value into a tab, and then I check if the first part of the tab is transactions. That means I know it is coming from the transactions file. What do? I increment the count, because I want to know the number of transactions, and then I increment the total also. So this is what is going to add the number of transactions and the sum of transactions. Make sense, guys? Let me have a quick look at the questions window. Kirti was asking, why are the classes as static? Is it a common coding practice in Hadoop? Hey, I'm calling the classes as static so that I don't have to create an instance of it in the driver code. These are all inner classes, right? So if you look at this is the main program. So there are two ways of writing it, Kirti, if you recollect last time. Either you can have it as separate classes, or you can have it as inner classes, right? So we are following the concept of inner classes. Good, Kirti. Mallikarjuna had a question. He said, MapReduce debug. How can I print out the right key and value pairs while running few programs? I'm getting string array out of bounds exception. I'm sure the data is in HDFS, and also I can print out the HDFS data. Hey, in case if you are getting that error, that is because you are putting in a wrong file. The index is going wrong. Okay, when you're doing the debugging, Mallikarjuna. So what you need to do is a simple SOP statement will tell you where you are getting the null values. See, like for example, if I pick up my index number 5 in my customer file, it will give me an error, right? Because the data is not there. Index is nothing but the value here. See here. Let me go back. Mallikarjuna was asking me, hey, Vijay was saying, I got the same error, forget to give the output path. See? So Mallikarjuna, what you should say, index is nothing but, see over here, I said 0, right? Array, right? That's why you're getting the error called as an index out of bounds. Here, I said I want to pick up my third value. Third means actually fourth. It starts from 0, right? So if you put in some value which is not there in the file, it will give you array index out of bound exception. Got it, Mallikarjuna? Please try that out. Fantastic. So now coming back to our code. So what have we done over here? I have got for an individual customer, I have got the total count of transactions, and I have got the final value of the transactions. And then I also check if the first part contains cust, I will assign whatever is there in cust to the name. So once I finished with this for loop, I know that all the values have been processed. So what do I do over here? I create a string wherein I specify the count and the total. Okay, so this is both the count and the total would be there in a value called a string. And what do I write? I will write the name and the string. So what will I get? The name, the number of transactions, and the total value of transactions. That is what I'm doing it in my reduce function. Cool. So now Nandish was asking me if the transaction ID to the account hash was in the third file, how can I achieve the same output? So my input are three files: customer info, the transaction file, and the transaction account to the account ID. Very good. So in case if you are having three files, what you will be having is you will have to have three mappers over there. Exactly, Vineet. That's what Vineet said. You will have to use three mappers, and then something should be common in between all the three files. Okay, and then you can do it. Make sense? Or the other way of doing that, Nandish, is if you don't have something that is common in, let me give it with an example. So let me copy what he had mentioned. So if there are three files, let me go back to my day9.txt. Let me do a word wrap over here. So the strategy should be you are having a cust file, you are having a txns file, and you are having an account file. Okay, so the thing that is common over here is the cust ID. There is a thing that is common over here is again a cust ID, but transaction file also has got something called as a account ID. The account ID is not there in the cust file. Let's assume hypothetically, okay, and the account file has got something called as an account ID. So we will have to use two jobs here. So we will have just one sec, we will have to use two jobs over here. The first job will join the cust and txns file and get an output. The output will be as input to the output will be joined along with the account file for further processing. If they have got the same common thing in all three of them, then I don't have to worry at all. Make sense, Nandish? So we are talking really good use cases over here. So make sense? Cool. So let me go back and continue with this. So let me have a look at the questions window. Fantastic. You're welcome, Nandish. So now we will go back and the configuration, the job, and all of those things are the same over here. But look over here. Now since we have got multiple files, earlier we were using something called as file input, right? So now I will be using multiple inputs and I will be specifying the different paths over here. What is going to be your input format class and what is going to be the mapper for the file that you are passing. So please remember the order of the files is important. The first file that you have to pass is the customer file. Second file you have to pass is the transaction file. So this is something again new, like we had used file input format earlier. Now you are using multiple input format. And then I say what is going to be my output path. I check if the output path is there. I would want to delete it because I don't mind overwriting it. And then I send my job for completion. And this is what is the path for the output. Okay. So in case if you're having three things, you will have to have multiple inputs three times. I can go back to the PDF. So this is what was the demo of the join that we had. Okay, joins in MapReduce. Let's go down to the next slide. Now guys, you know for a fact that the way how the records will be splitted would be based on something called as the input format, right? So you will have an input file. The input file will have an input split. You know what is a split? A split is equal to a block. The record reader will constantly look at the input split, okay, get key value pairs, and that is what will be given to the mapper. Okay, so who is going to convert that input split into a key value pair? It is going to be your record reader class. So the record reader will push it across to the mapper. The output of the mapper is going to be stored in the intermediate directory. Guys, where is the output going to be stored? If you can let me know. Suddenly I forgot, friends. Where is the output of the mapper stored? I'm waiting for somebody to answer. Okay, Vijay is saying HDFS. Vineet is saying temporary. Praveen says local temp file. It is there in the data node. Prasanna says HDFS. Okay, he changed it. Good, Prasanna. I was shocked to see you giving me that answer, but then good, he suddenly changed it. That's nice. Exactly. It will be there on the node in a temporary space. Very good, guys. It will not be in HDFS, Vijay. The final output of the map reduce would be in HDFS, but then the output would be stored in an intermediate space. Okay, friend? Cool. So that's the way how it would happen. Cool. Fantastic. So that's nice. Manish was saying, what is the small input file here shown for? Just once again, where is the small input file, Manish? Hey, just showing you what is it. It's the same thing, friend. Whether it is a big input file or see, there was no need for it to be actually shown. This particular section on the right hand side was not needed at all. Okay, they're just showing you whatever might be the size of the input file. This input file goes into one block. This input file is a big input file which will go into 3 blocks so that it will be done parallelly. That's what we are trying to convey over here. Nothing significant. And just to let you know, guys, the Hadoop Definitive Guide version 4 is already out. Okay, so unfortunately there is no free copy of it available as of now. So you might have to buy that. Okay, cool. But just letting you know that that is already available now. The 4th edition of the Definitive Guide. 3rd is good enough, but in case if you want to go deep dive into and read some latest thing, then version 4 is already out. Okay, let's move on. So there are various types of input formats what we are having. You will have the default as a text input format, which will be based on the new line. You will have a key value input format where in the same record you will have the key and the value. If you are having multiple lines and like address 1, address 2, city, state, pin code, country, okay, you might have to use an inline input format. There is also a sequence file input format what we will be seeing in our example today, wherein it could be a binary input format or else it could be a text input format. Okay, then you can also even have a DB input format. So the purpose of the input format is there are a lot of predefined classes for specific use cases. We are going to see an example where we are going to create our own custom input format also. Okay, guys, so what is the purpose of the input format? To identify what is a record. Let me go ahead and document it. The purpose of the input format is to specify the record delimiter. Okay, so based on this input format is what the record reader will break a record into key value pairs. Okay, so this is what is very important. So by default in the job class there is job.set input format. If I don't say anything, the input format is going to be text input format. Okay, guys. Similar to the input format, once I finish things, there would be a output format. So the reducer, once it's finished, will take the help of the record writer, like a record reader, and put it into the output file. Now, how many reducers will be there by default, guys? It will always be one reducer, my dear friend, because the output has very good Dheeraj. It will always be one reducer, friends. Okay? Fantastic, Vijay. It's going to be one. Okay? It is not going to be per mapper. No, not at all. The mapper is based on the number of block size, whereas the reducer will always be 1, unless you specify it in a reducer logic, that is in a partitioner example. Okay? Exactly, Nandesh. Hey Vijay, the slide is misleading, is he saying? No, my dear friend, what are we trying to say over here is the reducer will use the record writer and put it into an output file. Don't think that there will be multiple reducers. Each reducer will keep on looping through the values and then show it. So similar to the input format, there is an output format. So by default, it is going to be the text output format. You can have a DB output format. You can have a sequence file as a binary output format. Okay, you can have a null output format. That means nothing is going to be coming out of the reducer. Okay, so there are various output formats, class hierarchy also. So now we are going to go down to the example where I'm going to create a custom input format. So let's go ahead and see that. This is the most complex example of the whole course. So let's go back and check that out. So where is that? So this is custom input format. Okay. So guys, this is purely for Java guys. So let me open up the example so that it becomes clear to you. Let me close my joins program window. And here we are going to see a custom input format. We are going to show how to start from scratch. Manish was saying in what scenario we would have nothing coming out of a reducer. When I simply want to do sorting, okay, sorting of the data, I don't need anything coming out of the reducer. When I simply wanted, like in Hive, when I say select column 1, column 2 from the table name, I don't need a reducer. When I use scoop, again I don't need a reducer. So some common use cases, Manish, where I might not need a reducer, friend. Okay. So if you're implementing a custom input format, so when will I want to do that, friend? When we want to gain more control over the input data, as well as to support some very specific proprietary or application specific input data as input to your MapReduce computation. So this is really a thing that we will be doing it at that end. Okay, cool. Okay, good point, Malikarjun. So what you will have to do is you can go down and you will have to, there is a, we are using Gen 2, right? So just Google, there is a property key that we will have to enable. So you will see that aggregations are enabled. Or if you go down to your Windows, the normal Linux system, you will see something called as user logs. Okay, in the user logs, look at your job ID. Okay, and you will be able to see that. One is looking at the browser. That's a very good point what you brought about. So you will have to enable aggregations. Okay, and second is at the place in your Linux where you have got your Hadoop, USRlib Hadoop, there will be something called as user logs. In the user logs, you will have to look at the job ID and look at the attempt for the job. You'll be able to see that, Malikarjuna. Please try it out and keep me updated. Good. So now we are having an example of some sensor data. Okay, so this is how the sensor data is going to be. You will have a sensor ID, the device that is going to generate that. You will have a timestamp when the ID was generated, some kind of a status, and some values that is very specific to the application. So if this is what you would want, and here if I want the key to be a combination of your sensor ID, timestamp and status, and the value to be a combination of value 1 and value 2, I will have to create my own custom input format. So any input format implementation should always extend the input format abstract class, and there are some methods that you will have to override called as create record reader and create splits. Why record reader is important? Because record reader will convert a record into key and value, right? So in the above example, we are going to create an input format and a record reader for the sensor data. Okay? So this input format will generate customized my key instances as key and my value as value. So what are we doing here? We are creating our input format, we are creating our record reader, we are creating a key and a value. Because the key is going to be a composite key here, right? Key is not going to be a single key like a text or int writable that we were doing earlier. Okay? Hey, no problem, Sneha. Welcome back, friend. So we had finished off with one example of our map set join, and now we are talking about input formats over here, Sneha. Cool. So this is what we are going to do. So these are the steps that is needed. So this is something that I have written specifically. So I'm going to put this into your text document that I'll be sharing. This is for the custom input format steps. Okay, so let me remove this. So first, what should we do? We should create a key class. And what is the key class that we have over here? So let me just rearrange this and show it to you. The key class is going to be the myKey class. Then you will have a value class as the myValue class. Your input format is going to be my input format. Your record reader is going to be my record reader. You will have a mapper and you will have a driver. Where is my driver? Just one sec. My file. This is your driver code, and this is what is going to be the input data. So if you look at the input data, you see over here, I have deliberately kept only 3 values, but you can have multiple values also. Okay, friends? So this is what we're going to do right now. So let's continue. Let me go back and look at the input format now. First, let me open up my myKey.java. Okay? So if you look at the myKey.java, the myKey, all keys should implement your writable comparable. Why writable comparable? Because the keys are going to be sorted, right? So that's the reason in Java you will have to implement the comparable interface, and all keys should implement the writable interface also. So that's the reason why you're having writable comparable. What are the 3 things that is going to be there in that key? The sensor type, timestamp, and status. See over here, what I'm interested in is the sensor type, the sensor ID, the timestamp, and the status. That is what I want as a key. Okay, got it, guys? Now, if you look at the Java code, you know what is this? A default constructor and a constructor which will take up the individual values and assign the class variables. Okay, you have to override 3 methods which is there in the writable comparable called as read fields, okay, which will take the data input. You will have to override the write method which will take the data output, and the compare to method, because if you implement comparable you have to override the compare to method. So here what am I comparing? I am comparing each of the types, and then I am saying what should it return. Okay, it will return me which one is the, if you look at the comparable, the order is important, which one I should pass. And then of course you will have the getter and setter methods for all the 3 variables. Okay, so this is how I'll be writing my comparable key. Okay, so all keys should always have read fields and write method to be implemented. Just for the purpose of understanding for people, let me quickly go down to my API. I'll go down to my D drive. I'll go down to my Hadoop Linux. Okay, I'm there over there. I'll go down to my software. I'll go down to my Hadoop. I will go down to my docs. Sorry, it is in share, doc, Hadoop. I'll go down to my API, and in API I will click on index.html because I wanted to show you what is this comparable. So let me go down to org.apache.hadoop.MapReduce, and I wanted something called as writable comparable. Let me look at the API, which is the class. It's in hadoop.io. So I needed to go down to hadoop.io. There it is, hadoop.io. In hadoop.io, I will look at the writable comparable, and you will see over here, see here, the writable comparable can be compared to each other. Okay, any type which is to be used as a key should implement this interface. Okay, and they're giving a lovely example also. Okay, just one sec. They're giving a very good example of how you should write the method called as write, read fields, compare to. Okay, and they will give you a good example of how it is to be done. Okay, friends? So that is how we have got this class written. Now after the key, I'll have to write my value. So let me go back to my next class, that is my value. What are the 2 values that am I going to have here? Value 1 and value 2. And like the last time, like the last two examples, what we are having, I will have a constructor, the last key, you will have a parameterized constructor, you will override the read fields and write method and the compare to method, and you will have getter and setter methods. Okay, so we have created our key. Okay, we have created our value. Okay, now we are interested in creating our input format class. Okay, so let me go back. So now let me go back to my input format class. That is my input format. So what is the purpose of the input format? To identify what is a record, right? So see over here, I'm extending a default input format in which it will take a key and a value. There is a method called as create record reader, which will return a record reader type. And what is the record reader that I want over here? It should return my custom record reader that I'm having. So only one method that I have to override here, wherein I have to say what is my key, what is my value, and how will I identify new records. So all that logic is there in your record reader class. So let me go back quickly and show you the record reader implementation. So I am extending the default record reader class over here. Okay, I am creating a line record reader so that I know that in my data also it is going to be a new line. I will have to override a method called as get the key, get the value, because what is the purpose of the record reader? To identify what is a key and a value. Okay, there is going to be a method called as initialized, wherein you will initialize what is an input split. There is going to be a method called as next key value. Okay, so once I get a key, see here, what I will do over here is I got the whole record. So what is my data file? Let me show that to you. This is what is my data file. So based on the line record reader, I got this whole record. So now what is the key and what is the value is what I have to see, right? Ideally, what will be the key? The key will be the offset position, the value will be the whole record, right? That is what is the implementation of the default record reader. But in my example, you see here that I'm getting this whole record. Out of this record, the first three things are the key and the next two things are the value, right? That is what is the logic that I'm having it in the method called as next key value. See here, I will get the key and this is what will give me the current value. So based on the new line, it will give me the whole text. Okay, then what I do, I split the text based on tabs and then see how I will add the first three things to the key and the other two things to the value. This is the way how you will be implementing it in case if you are creating your own keys and values, friend. Okay, that's it. There is nothing else in this particular class. So what have we done? We have identified what is our key. We have identified our value. We have identified our own input format, and we have identified our own record reader. Now we are going to use all of these things in our code. So let me go down to the mapper and show you how to use this. So let me go down to my mapper. Before I go over there was a question. Let me look at this. Madhu was asking, in case of binary files, how do you identify the key and the value? Typically in the case of binary files, it will be a byte array. Okay, so like we created our own class over here, you will have to create a byte array class, and typically one file would be one byte array. So every file would be considered as a key. And if you wanted to know a little bit more on that, Madhu, there are ways how to do it. So let me go back to this and show you how video analysis, MapReduce video analysis, and if you look at this pivotal API, okay, so they will actually show you how to do that, and then there is a good YouTube video also which will talk about video analysis. So there is a pivotal blog wherein they are showing you how to create your own MapReduce. So if I click on this, large scale video analysis, using pivotal. Let me scroll down. Okay, you will actually see the code. Let me go down and show you how the code is. So I've actually seen that code before. Not this link. Let me go back to the next link. Video transcoding. They have, see how to get the sequence header, the chunks, what is a sequence header MapReduce job. They're given the whole code also. See here, input, keys and values, and see what is the example that I said. It is going to be a byte writable. Got it, friend? You're welcome, mother. Okay, so let me close this and let's continue. So now in the mapper, what is my key? My key, my value, output is going to be text and text. Okay, then what do? From the key, I get the sensor type, and if the sensor type is A, I want to get the value. So what is the business logic that I'm having over here? Out of all of the data that I'm having, imagine there are multiple sensor items that you're having. I'm interested only in one sensor. Here only there are two things for the purpose of simplicity, but in a real world, because I've been consulting Tyco. Tyco is a fire and a safety equipment company. They are big time into big data now because the amount of data sensors that they're having is simply crazy. So they wanted to analyze the data based on the sensor type, what is the readings, what is the probability. Okay, so they would see what is the average temperature in a particular area. Okay, and if it is high, they would give suggestions and improvements how to reduce fire and all of those things. So they will have more than 60 to 70,000 sensors. Okay, they would want to analyze those sensors, etc. So for doing that, they will be having 60 to 70,000 sensor IDs, and I'm only interested in one of the sensor ID over here. Okay, and then comes the driver code, the last part of it. So if you look at the driver code, that is going to be myfile.java. Okay, see, it's the same thing, public static void main. You create a job, but look at this. There is no reduce task over here. So lovely example where I'm not interested in a reducer. But look at the input format. See here, job.setInput format class is going to be my input format class. Of course, the mapper and key value class you will know. And then I am putting in a file and I'm getting the output of it. So the new thing that I have shown over here is how to create your own custom input format, and the steps that we have is these steps. Create a key class, value class, but if you don't want to create a key class, value class, even that is fine. You can create your own input format and record reader. Okay, you can create, if you are having your own key class, value class, then you will have to create an input format and a record reader, and then of course your mapper and driver and reducer would be a part of your own code. So this is an exhaustive example of how we are analyzing our custom or creating our custom input format details for you folks. Okay, so let me go back to my PDF. So this was our demo. Now let's get down to the next example. Before I go ahead, I just wanted to come back and check with everybody. What are the two examples that we saw here, guys? We saw an example of how to use your joins, MapReduce joins. That is, we specifically looked at reduce side join. Then we saw the second example that is going to be creating your own custom input format. So now let's move on. The third example that we are going to see in our Advanced MapReduce is going to be how to use your MRunit, that is unit testing. Unit testing of the code. Okay, so why would I need unit testing of the code is because I would want, so let's move on, guys. So let's talk about unit testing. There we go. So JUnit, as you would know, is something that the developers use to unit test their code. So what do we have to unit test over here? We will have to unit test our map function and our reduce function. So by default, the framework, that is MRunit. So if you want to learn more about MRunit, please go down to Google and search for MRunit. There is a very good tutorial that is available. I'll share that with you. See here. the wiki page has got the latest MRunit tutorial, and this is that site. MRunit is a Java library which helps developers unit test the MapReduce jobs. Okay, 1.1 has already come last year. You can work on that. There we go. So if you look at the MapReduce testing, there are 4 types of drivers that is available. There is a map driver which will be useful for testing the map functionality. There is a reduce driver which will help the reduce functionality. There is a MapReduce driver which will help me to take one run of the map and the reduce together. And then there is a pipeline MapReduce driver which will allow me to test multiple MapReduce jobs. So it helps you to fill up the gap between the MapReduce program and JUnit, and it is better to, you will have a better control on the logged messages with JUnit integration. That is what is this Apache MRunit all about. Now let's see an example of it. Okay, so we are going to go down to the example to understand what is this MapReduce or MRunit. So we have seen an example of our join program. We have seen an example of our custom input format. Now I'm going to show you the example of this MRunit. So let me open up the document that is there for MRunit. There we go. Let the document come up. Couple of seconds, guys. The document is coming up. Come on. Give me a couple of seconds, guys. What happened to my word? There we go. So the document has come up. So for doing this, you will have to download. This example is showing you version 1, but you know that version 1.1 is already available. You can do that. You will have to download this particular jar file. Okay, see over here, we are giving a screenshot of how the jar file will be. Okay, then if you expand that jar file, there are a couple of jars that is available. Okay, so you can look at those jars. So import all the jars to the lib directory in the Eclipse project. You know how to do that. So we are just showing you screenshots of how to do that. You will have to add the external jars. Select all the jar files for the project. Just simple screenshot of what we have done till now. Okay, and finally showing you how the jar files will be friends. Okay. So now for running the mapper, there are actually 5 steps. Okay, the first step is you will create an instance of the map driver class, parameterize exactly as the mapper that you are testing. Okay, why are we doing an instance of the map driver class? Because we are doing a map testing. Okay. Cool. So first you will create an instance of the map driver class. Then you will add an instance of the mapper you are testing with the withMapper call. So there is a method called as mapdriver.withMapper. You will do that. Then you will have a with input wherein you will specify what is the input and the output values that is going to go to the mapper. You will specify the expected output. So people who know JUnit, it is exactly like JUnit. You specify the input and the output. And finally, you will call the method called as run so that it will execute that map for you, friend. Got it? Fantastic. Hey, Vijay said batch processing cannot be debugged. Hey, that's true because typically it is not that it cannot be debugged. You'll have to do a remote debugging, and it is going to be because it is going to be on a cluster, right? On a single node VM, you can do debugging, but not for a clustered environment. So let's see how this is actually done with the help of a code so that you will understand these things. Exactly, Vijay. Thank you, mate. So let me scroll down. So here we are saying the map driver only allows one input and one output. So if you are trying to call it multiple times, it will overwrite it. This is just as a tip so that you'll understand it. Cool. So let's move on. So this is the program. I'm just going to, instead of showing it to you over here in a Word document, I'm going to open up the Java file. That will make it more easier for us. So there we go. Let me do a word wrap. So what are we doing over here? We are having a class which will extend the test case because this is going to be a a JUnit example. Okay, so then this is the actual MapReduce code. So I've got a map test which extends mapper. In the map, I have got some business logic. So this is the class from 16 to 26, which is going to be the actual MR code. Then I am having the testing code over here, wherein, like I said, first we have to declare our map driver, which will have the same parameters as that of the class. Then in the setup method, I'm creating an instance of the map driver and I'm passing the actual class. Then using @test, I am testing it with the input, with the output, and then I will run the test. That is it. So here I am tightly coupling my MapReduce code and my testing. Okay, in another use case, you might have your MapReduce testing code to be separate from your MapReduce code also. So that is also very much possible. If you are having it that way, then you might have to use package name dot class name over here. Since the map test is within the same class, I've directly said new map test, but then if your class is in a separate package, please import that particular package and use it appropriately. Here I have tightly coupled both the MapReduce code and the testing code, which might not be the case in some other situations. You might have the code somewhere else and the testing would be somewhere else. Okay? So this is your logic of your MapReduce, folks. Okay? So let me say quick close all, and I just wanted to open up my day9.txt. There we go. So this is clear, and let's continue with our PDF. So we have seen our example of unit testing. Okay, now what is the fourth thing that we have in our plate today? You know there are counters, right? Hey, let me go back and have a look at the questions window. Hey, the reason is because the choice is up to you. Here I have derived from the test case because it's a JUnit part of it. Okay, you can do it without doing that also. So both the possibilities are there, Vinith. You can always extend from the test case so that it can be a part of a bigger program, or you don't have to do it also. So both options are there for you, Vinith. We have just kept one option wherein we have derived from the test case. Okay. The fourth example that we are going to talk about is counters. You know, counters give you statistical information. So you can see over here, they are lightweight objects in Hadoop, which allows you to keep a track of how the system is progressing. Like, for example, when you're downloading a file, you will of course want to know what are the percentage of download that is done, right? So that's an example of counters. Counters are used to gather information about the data that you're analyzing, like how many records you have processed. If you are having some invalid records when running a big job, it is always better to not do that. Okay? So counters are lightweight objects in Hadoop, which will allow you to keep a track. And you see that when I run my job, there are file system counters and job counters, etc. We are going to see an example of how that is going to be done. Hey, Vijay was asking, will counters be based on the number of lines or based on percentage? Hey, counters are something that will be across the cluster. So whenever you run a cluster, you will see how counters would be there. It is not going to be on a percentage or anything. It is across all the nodes in the cluster. So let me go down to the next slide. So let's have a quick demo on the counters. What is counters going to be? So let me go back to my folder structure, and I'm going to go down to the counter sample. Okay, so this is what is my input data. Let me quickly open up my input data. I have got some numbers and I've got some timestamp. Okay, just 4 small values so that you will understand the purpose of the example. Then I have got a problem statement like what we always have. So how is counters going to be useful in our custom metrics? Okay, the basic purpose of counters are to report the base statistics of a job. So let's assume that you have got a data set with timestamp. If you want to check how many month-wise records are processed by our mappers, we will have to use counters. So in the timestamp, what you are seeing, the timestamp will have the day and the month. So let's say you have got about 1 million records, okay? So in that 1 million records, I'm interested in finding out before the job gets completed, approximately how many records are there for, let's say, a particular month. Okay, this is not the final result. Okay, the final result is known. That I understand. The final result is going to be once the whole job is finished. But in between that, if I want to get some statistical information, I will be using my counters. So we are going to see how to do that. Okay. Now there are a lot of built-in counters that we have. Hey, before doing that, a quick example. Vijay was asking, is it possible to implement some custom log feature which we can where we can write the execution step in a separate log file at a specific location outside of the framework other than inbuilt framework log? No, Vijay, because you can of course use your log4j and do that, but then the framework will are you asking, can I have a specific log4j? So you can have a log4j at the application level, yes, okay, but then any default logs that needs to be printed out at the mapper or the reducer, that have to be within the framework. If you're talking about a plain log4j, then yes, you can do that. So now, some of the built-in counters that is there in Hadoop is going to be the task counters. What is the input record, what is the output record, etc. The job counters, how many jobs was launched, how many maps was there. You can always create your own custom Java counters. So for creating a custom counter, first you will have to create an enumeration. Okay, the enumeration will have the values of whatever you are going to count. So in this example, we are going to have missing and total. Let's say hypothetically, missing is used to maintain the count of missing records, and the counter total is used to maintain the count of the total number of records. Let's say my job is going to run for about 4 hours, and in between that I wanted to check what is the percentage of your missing records vis-a-vis the total records what we are having. Okay, so you will have to create a counter for it. Please remember, counters are global. Their values are shared across maps and reducers, and it is aggregated at the end of the job across all the tasks. Okay. Hey, Mallikarjun said you cannot use it in MapReduce. I said you cannot use it. When I said I cannot use it in MapReduce, what I meant is you cannot, the default sysouts, what you're writing, will go to the log file. If you wanted, instead of writing a sysout, if you want to say log4j.log, then you can do it, friend. Make sense, Mallikarjun? Hey, Ananda, log4j is a tool which will allow us to print the logs to a particular directory. So if I would have been there in your case, just give me one sec, guys. Sorry, I'm just moving away from topic. So what I would suggest is for you to just search for log4j, and you will see that it will give you a way how it's a logging library for Java. And if you look at tutorials point, there is a very good log4j tutorial. Tutorials.point.com is very good. They have got some Hadoop stuff also there, although it is pretty basic. Okay, but still you can do that. Cool. Dheeraj said, are counters going to add overhead to the long-running process? No, not at all. Okay, it is not going to have any overhead at all, friend. Cool. Now coming back to what I was saying, counters are global. Okay, so the counter values are shared by all maps and reduce jobs across the framework. Now, how do I use a counter? I have created a counter in the form of an enum. You can use the counter either in the map function or in your reduce function. You can say context.getCounter and you can increment it based on some value. Okay, this is how the logic is. So now we are going to see an actual example of how it is going to be done. So let me go back to the Word document, mycounter.java. Okay, so you can see over here, I have got a enum called as month. Okay, I am deliberately checking whether it is going to be December, January, or February. So you see here, I have got an enum called as month. Okay, and I have got December, January, February. I wanted to see how many counters are there in this particular month. Similarly, if you're doing the transaction example and you wanted to find out whether the records, the transactions are coming in the California, Florida, or the Ohio state, I can create an enum for the state also. So just showing you how to create a counter. Then in our mapper logic, what are we doing? We are putting in on the same value. I am using the split. So you know what is the input data? The input data is going to be, there are two values. There is going to be 0 and 1. This is where the timestamp is going to be. That is 1. So see what am I doing over here? I am first converting that into splitting it based on a comma. Then I am taking up the first string, that is the date, and I convert that to a date. From the date, I get a month. Okay. Then what do I do? If the month is going to be 11, I will know that it starts from 0, right? So that's why I will say that the December value should be incremented by 10. If the month is going to be 0, that means January, it will be incremented by something. If the month is February, it will be incremented by something, just to give you a logic. Similarly, if you wanted to show if how many records are there for California, for Florida or Ohio, I'll simply say context.getCounter. Okay, what will I say? Instead of month.December, I would say over here state.California, okay, dot increment 1. Similarly, I will increment, if it is for Florida, I'll increment by 1. If it is for Ohio, I'll increment by 1. Just giving an example of how I will increment the counter in my mapper or in my reducer. Finally, I wanted to print it out, right? So that will be done in my driver code. The final printing out will be done in my driver code, and this is the way how you'll do it. You will say counters is equal to job.getCounter, so you will get the complete list of counters, and then you will check if counters.find counter of that particular value, whatever is the enum dot something, and then I will say get display name, and you will get the value of it. Similarly, if it is Jan, I will show the display name, that is whatever is the display name and what is the value of the counter. So this is what will actually show you the counter values. Okay, so when I say this system.out and display, it will actually be printed in the console for you. Okay, so what are we doing? We created a counter. We use that counter in the mapper or the reducer, and in the driver code we have simply printed out the counters. Okay, so that is the way how you can create your own custom counters, friends. So please try this example so that you will understand how counters are going to be used. Okay, so the steps in the counter is A, create the enum for the counter. B, use the counter in the map or reduce function. And C, display the counter in the driver code. So that's it, guys. So these are the different ways how counters can be used. So what we have seen is we have seen 4 things today. We started with our example of reduce side join, then we did our own custom input format, we created our MapReduce counters and MRunit unit testing, and then we saw our counters example. Now we are going to go ahead with the next one, which is going to be an example of our distributed cache. Okay, so what are we going to do in distributed cache is, let me go back to the folder and explain that to you. So let me go down to the distributed cache. There we go. So let me go down to the PDF first. So hey, let me look at the questions window once. Somebody has asked a question. Hey, Nandish was asking, can I write the counter output to a HDFS file? Right now, no, because see, when I say counter output, counters is going to be done at a sequential level. So once all the counters are finished, okay, that value you can assign it to something. So so typically don't think it of like a counter. that logic of writing to an HDFS file has to be a part of your MapReduce map and reduce function. Whatever you use in context.write in your reduce is what you can write it to HDFS. Counter values are typically incremented, and that logic is typically displayed while the program is running, right, Nandish? So that's the reason why primarily it cannot be written to the HDFS file. If you want to do some values, that business logic has to be written in the reduce, Nandish. Hope it makes sense. So what is caching? So cache is a facility by the MapReduce framework which will allow you to cache some files that is needed by the application. So files are copied only once per job. So imagine you are having multiple nodes. So in one node, for every record, if I wanted to look at some other reference data or lookup data, so in my transaction example, if I'm having 200 MB of data, 128 MB will have more than X amount of records. So instead of calling an external file every time, it is better to cache it in that particular node itself, and that is what it is going to happen. So files are copied once per job, and ideally should not be modified by the application or externally when the job is executing, because a cache of that is what will be used for in the map function or reduce function. So cache can be used to distribute simple read-only file, text files, or it could be even your archive, jar, etc. via the job conf or the job class. Okay, both of them can be used. Let's go ahead and see an example of our distributed cache demo. So let me go down to the folder of distributed cache. First, understand what is cache. So I'm going to open up the document, and then we will look at the problem statement. So I have just opened up the cache document. It will come up soon. Let me close my counter example. Wait for a couple of seconds, guys. The document will be up soon. I don't know why my Word is taking a little bit more time today, but then that's okay. There we go. So it should come up. So what is cache? When we write applications using MapReduce, you may have to share some files across all nodes in the cluster. It could be a properties file, or it could be a jar file. The framework allows us to do this via something called as distributed caching. Okay, so anything that is needed by the applications when they are running it, it is better to do that with the help of cache. So applications specify the files via the URL. Typically it is HDFS protocol, and they can be cached via the job conf or the job class. But please remember, the cache assumes that whatever files that you have specified is already available in that particular file system. And then the framework will copy that file onto the node before any task is executed on the node. So this is what one of our other participants have asked. What will happen in case if something goes wrong and you are not in a position to run some file, etc. So in such cases, when I meant you are not able to run some file, what I meant is the node has gone down. In such case, the framework will again copy that cache on the node before it gets executed. Okay, so clearly the cache file should not be modified by the application or externally when the job is executed. So how do we do it? First, ensure what needs to be copied into the shared drive. Okay, so whatever data is there, that should be there in your HDFS. And then using your job or the job conf, you can add the cache file by giving the URL, and that cache file will be there for that particular job. Okay. Then once that is done, then in the mapper class or the reducer class, you can use distributed cache dot get local cache file, getting the configuration, which will give me the complete array of path. From the array of path, I will pick up whatever is the file that I want, and I will use that in my code. So you might be wondering, what is this setup method? So there is a lifecycle method of the mapper, there is a setup, there is a map, and then there is a destroy. Okay, so setup is called once every time before the mapper starts. So the setup method, in the setup method, you will put something into the cache. So this is the way how it will actually be used. So what are the steps in the cache? Let me just document it over here. So the steps in the cache is point number A. Let me use a tab so that it will be consistent. Point number A, have the reference data in the HDFS first. Then B, using a distributed cache, add the reference data to the job, okay, and then in the mapper or reducer code, use the reference data via distributed cache. Okay, so a simple 3-line step is what we need. Let me go back to the questions window. Is cache for read only? Exactly. So cache is going to be static data that you are going to read. It's not going to be dynamic data because the original file should not be modified, right, Vijay? So now let's look at the problem statement. So there we go. So the problem statement that we are having over here is I am going to use distributed cache to find out lines that contain some keywords. Okay, so let's take an example. We are going to use this distributed cache recipe to associate abbreviated data to a detailed file that is there in the cache. So let's say you have got some original data which is going to be like this. Okay, UP some values, MA, Maharashtra, Bihar and West Bengal some values, and UP actually means it is Uttar Pradesh, Maharashtra and Bihar. This is what is called as the reference data. Okay, so what I am interested in is I'm not interested in UP. Yes, when I say UP, I should know that it is Uttar Pradesh. In the final output in HDFS, I should show that it is Uttar Pradesh. Okay, so then what do? Then associate the file in the mapper and the reducer program where we can write the logic to associate this detailed information. So this is the logic that we're going to have. So if you go back to the data files, your DC input, distributed data input is what is your actual data. Okay, the reference data over here is going to be my lookup.dat. That is what is going to be a reference data. So the lookup.dat should be there in HDFS. See, the reference data is lookup.dat. That should be there in HDFS first. Then using the cache, we will add the reference data to the job. Let's see how to do it, how we are doing it in the code. So I'm going to open up my dc.java and you will see, let's first go to the driver. Okay, see here in the driver, what am I doing? I am first saying add cache file that lookup dat which is there in HDFS and I will get it for that particular job. Okay, so I have already added that to the cache. Then in the mapper class, okay, see over here in the mapper class, this is the mapper class, I have got a method called as setup. So setup method is called once before the job actually gets executed, right? So in that I am saying distributed cache.get local cache files. It will return me a set of a path or location which has got that particular file. So if that file name is lookup.dat, okay, that is the actual file that we have, then what am I doing? I'm using buffer reader to read that particular file. Okay, so what is there in that particular file? You have got some key, that is abbreviated value and the expanded value of that particular key. So what are we doing over here? I'm splitting it by tab and then I am getting the abbreviated value and the actual state out of it, and this value I'm putting it in a map. So a map is something that is a global variable, that's a hash map for that particular class, okay? And I see over here how am I putting that into the map. And then I will say reader.readline, that means it will keep on reading everything. So this whole file, lookup.dat, okay, whatever might be the size of it, it is there for me in my map function. Okay, in a hash map it is readily available for me. And when is the hash map populated? For the first time when the program starts. Okay, cool. Then what do I do? In my map function, what do I get? I get the actual value. What is that actual value? This one. Sorry, not this one. Let me close this. We are talking about DC input. UP and the state. I'm getting those values. Okay, I'm splitting it by tab. This is the abbreviated value, what am I having, token 0. And then what do? I pass that abbreviated value and get the full state. Okay, so this is the expanded version, that is Uttar Pradesh and not UP. First I get UP, which I will pass it to the map, and from UP I know that the actual state is state, and then an output key I'm putting it as a state, and the output value I'm putting in as the whole row that I want. So what is the whole row? So the whole row is going to be Uttar Pradesh space, that is a key, tab, UP, and so and so. So that's what I'm doing it in my code, and I'm writing it my whole value. Okay, just once again, this should be population. In case if you're only interested in the expanded version and the population, see over here in the comment how am I picking up the population. Okay, and then I am saying I'm setting the population as the value, so I'll get Uttar Pradesh and I will get only the population. But in my default example what I'm having, I'll get Uttar Pradesh, tab, UP space or tab the actual population. Okay, so this is the way how I'll be using the distributed cache. So distributed cache is going to be a small file which I'll be putting. So what is the example of distributed cache? A map side join. You're joining it on the map side, right? So you can see over here in my MyDC, that is the driver code, you are doing the joining at the map stage. See over here in the map stage is what you're getting the value from the map. Got it, folks? So this is the advantage. So if what is the limitation of distributed cache? There is a limited amount of data that you can put as much as what the memory of the node can hold. Okay, that is what it is, limited. Okay, so that is technically the only limitation what you have as compared to the other ways of doing it. So this was a quick example. So I would want you to actually try out all these examples. Okay, my job is to go ahead and explain all of these things to you, and I have done that. I would want you to actually go ahead and try that. So after E, the next example that we are going to see is going to be the sequence file. So let me go back to the PDF. We saw the demo of the distributed cache. So now what is a sequence file? You know that Hadoop is not restricted to processing plain data. Remember, one of you had asked me, can we see some example of binary data? We are actually going to see an example of binary data over here in the sequence file. So for custom binary data, one can use sequence file. So what is a sequence file? It's a flat file consisting of binary key value pairs. You can use MapReduce sequence file as a MapReduce input or output format. And please remember the output of the map. Okay, we know that the output of the map is stored locally in a temp file that is always stored as a sequence file. By default, a sequence file will give you a reader, a writer, and a sorter. Okay, so sequence file is a type of your input format, friend. Okay, so there are three types of sequence file format. Either you can have uncompressed key value pair, you can have record compressed where only values are compressed, or block compression is there where both keys and values are collected in blocks separately and they are compressed. So the first reason for the sequence file is when you want to use binary data. The second advantage of the sequence file, you can see here, the other objective of the sequence file is if you are having a lot of small files, okay, then we know that the performance of the MapReduce will be less because every file will be stored in one block. There will be a lot of time that will be spent in starting and stopping of your data, and the actual processing will be less. Remember, guys, this is a Hindi word. I'm sure most of you would know that. Charne ki murgi aatne ka masala. You would know that, right, guys? That means the whole ingredient is more than the actual cost. Make sense? So that is what is the second advantage of the sequence file. So sequence file for MapReduce computation is there because Hadoop prefers large files. Okay, it is 64 MB and 128 MB. So if you have got small files of, let's say, 200 files of 1 MB each versus one file of 200 MB. Hadoop prefers one file of 200 MB and not 200 files of 1 MB each, right? So these are the two benefits of your sequence file. Let me document it. So the benefit of sequence file is A, to enable binary data as a input format, and B, to compress small files into one big file. Okay, we are going to see both of those things in our example over here. So let me go back to my PDF. You would see, remember I told you there are two types of compressions. If you do a record level compression, what would happen is only your values will be compressed. If you do a block level compression, then your keys and values both will also be compressed. Okay, so these are various compression techniques what you're having. So in block compression, both your keys and values will be compressed, whereas in record, only the value will be compressed. So now let's take an example of a demo of a sequence file. This is a good example wherein we will see some use cases of how sequence file can be done. So let me go back to the folder called as sequence file, and let me open up the document that is called as sequence file demo. Here, let me have a look at the question. Mallikarjun was asking compression for memory purpose. No, compression is ideally because if I use the files, okay, let me ask you this question, Mallikarjun. Why compression? Okay, if the question is why compression, okay, let me ask you this question. If you have got one file of 200 MB, how many, just one sec, let me do a word wrap. Sorry, there we go. How many pointers we need in the name node? If I have assumed the replication is 3, if I've got one file of 200 MB with 3 copies of a replication, how many pointers do we need in the name node? Very good. We need Vijay, Manish, Mallikarjun, okay, Ananda, 6 pointers, okay. I would need 6 pointers. Now, if we have 200 files of 1 MB each, how many pointers are needed? How many pointers are needed in the name node? 200 files of 1 MB each. We need 600 pointers or 200. Why 600? We need Mallikarjun, it's only 200. Right? If you're talking about replication, okay, so there are 200 files, that means there is one block, okay, so there are 3 replications, so that's right, good. So that's the reason why if there is 200 MB, that means there will be 2 into 3s are 6, okay, that's how it came. Now if I've got 200 files of 1 MB each, it would actually be 600 pointers. So saw how the number of pointers are increasing, how the metadata in the name node will be increasing. Although in both the cases the file size was 200 MB only. Got it? Good, Vijay. Got it, guys? So this is one of the advantages. Second thing is, when we have a job, it has to load each of this 200 MB will be there in separate blocks. Okay? So just one second, there was a typo here. Okay, so each of the 200 MB files will be in separate blocks. The loading and the starting and stopping of the MapReduce task will be high. Okay, that is the reason. Hey, when I said compression, compression is to think of it like a zipping. Okay, here we are using the word compression for zipping, Mallikarjun. Make sense? Sure. So let's continue. So Mallikarjuna is clear on that. So now let's look at the example of the, just one sec, sequence file problem statement. So whatever I have explained to you right now is what is documented over here. Okay. Here, Vijay, we are not modifying the original, we are just zipping it together. When do we decide which compression type? Good point, Manish. Most of the cases you would want your values to be compressed, that is block compression, record compression, sorry. In some rare cases, you might want the keys also to be compressed, if the keys are big enough. In most of the cases, the values would be compressed. In some cases, the keys needs to be compressed. Okay? So HDFS is designed to store and process large terabytes of data. Storing small number of files is inefficient. Files and blocks are name objects and they occupy namespace. The namespace capacity is limited by the physical memory of the name node. When there are large number of small files, metadata occupies a large portion of the namespace, you know. So this is the example that we have already seen. Okay, so for example, a 10 GB file is broken into files of 100 KB each. Use a map of their own, so the time taken to finish the job increases. Understandable. Second is, Hadoop is not restricted for processing text data. For user custom binary data, you can also use sequence file, which is a flat file consisting key value pairs. Okay, so now let's understand our business use case. This is going to be our business use case. Before that, one final look at the questions. So Manish was saying, so do we all call compression logic and all MapReduce programs as a general practice? No, we don't do that. Because when we compress something, then there is an overhead on decompression, compressing it. You have to pass the codec and all of those things, right? So it is not a common practice. It is used in case if you have got some use cases like this, Manish. Okay. So let's say you have got a lot of small image files and need to remove duplicate files from the available data. That is my use case. So what is this? You've got small image files. So that is one problem. So using sequence file, I can compress it together. And second is you are having image files. So images are binary data. So again, that is the second use case of compression of sequence files. So as most binary data, particularly that is compressed or encrypted, cannot be split and must be read as a single linear stream of data, using such files as an input would mean a single mapper will be used to process the entire file, causing a performance hit. In such a situation, it is preferable to use a splittable format such as sequence file, or if you cannot avoid receiving the file in another format, do a pre-processing step that converts it into a splittable format. That's what we're going to do right now, guys. So let's go ahead and look at the use case. So we are going to have two separate jobs over here. One, we are going to create a sequence file from a lot of images. I'll show you the data. You will move the files to HDFS, prepare the list of files which has to be given as input to our mapper, use our binary files to Hadoop sequence files to convert. The input is going to be the file path and the output will be the file path and the byte array. We'll actually see this, guys. And in the second case, you will use the write a MapReduce program to remove duplicates from the given sequence file. You will run the image driver with the image duplicate mapper and duplicate reducer, and you will check the list of non-duplicated files. So the example that we're going to have over here will have a lot of images. Let me go ahead. I've extracted the images folder for you. So if I click on the images folder, you will see here that there are 3 types of images, but a lot of them are duplicated. 1, 2, 3, 4, 5, 6, 7, 8. 8 of them are duplicated and the other 2 are original. So we actually have only 3 original images over here, guys. All the others are duplicate images. So what should we do? Let me go back to the first example, that is binary files to Hadoop sequence file. We are going to convert the whole images into a binary sequence file. So see over here, we are having, let me do a word wrap. So what are we having? The output is going to be byte writable. So what is the input to that particular file? See over here, input is going to be the file path. Okay, so I should have some data file which will have the file path. So see over here, this is sequence input.txt. So this is what I have put in HDFS. I've got a folder called as images which has got multiple images. Okay, so the input is simply going to be a file path and the output would be a byte array, okay, of each file. That is what we're going to do over here. So let me go back and show that to you. So see over here, what do? I look at the URI, that is the value. Then I use the file system API. Okay. Then I open up the file system, convert the whole thing, whatever is the file. So I open up the file. What am I having? I'm having the path in HDFS, right? So I will read that particular path. Okay, then I will keep on looping through the path for every file and write it into my byte array. So what is the output that am I giving? I'm giving the file path and the byte writable of the complete array. That's what I'm doing over here. Okay. Exactly, Malikarjuna. The file should be in HDFS. That's why I'm giving the path. So see over here in the input data, I'm giving only the path. Okay, so for every path, I will go to the file system. Okay, I will go to the HDFS. I will open up that file system. Okay, and then I will read the complete file and I will write it into the buffer. That's it. So what is the output that is going to come? The location of the file and a byte writable, which will be the complete array. Good, Malikarjuna. Then after that, what should I do? If you look at the document, now I am going to have a duplicate mapper because I wanted to remove the duplicates, right? So if I go down to the code and look at my image duplicates mapper code, let me do a word wrap. Now how do I identify what is a duplicate? Guys, have you heard about something called as MD5? So I'm going to type something called as MD5. Sorry, it should have been MD5, not MD percentage. MD5 is a message digest algorithm widely used in cryptographic functions to produce a 128-bit, which is a 16-byte hash value typically expressed in a text format as a 32-digit hexadecimal value. Exactly, Vijay, Manish, good. Hashing algorithm. Dheeraj said, in this example, we are splitting the file, but in use case, we saw we are combining one file into 1 MB of 1000 files. Hey, that's correct, Dheeraj. What am I doing over here is, since I'm having a file, okay, so what I should do is a sequence file can be used to archive all the files into a single file and then use it, okay, or it can be used for binary data also, Dheeraj. Make sense? So see over here, I really have got the actual files in a RAR file over here. See over here. This RAR file has to go to the HDFS and this is the location in which it is used. I'm just giving you a use case of how to use it, Dheeraj. What are the two purposes of sequence file? To compress everything together into one sequence file so that you can use it, or to use binary files. Here I'm giving an example of binary files. Got it, Dheeraj? What are we trying to do over here? We are looking at every file and we are getting the byte array of it, friend. Cool. So if you look over here, now, like I told you, what is MD5? Okay, so it will give you what? It will give you a 32-digit hexadecimal number, and for a file, for a byte array, you can calculate MD5. So see over here how to calculate MD5 for a byte array. See over here. So how do I generate MD5, how to calculate MD5 and SHA hash values in Java. So there's a complete logic. There's a Java code that is there, and that is a Java code that is this particular code. See over here. Okay, so there is a method called as calculate MD5, which takes a byte array and returns me a string which is the hexadecimal 32-bit string. Because if I want to find out duplicates, exactly, we are using MD5 to find duplicates. That's correct, Dheeraj. You got it correct. Okay, so this is the logic. This I picked it up from the internet only. Okay, this is the complete logic. You can easily find out this code in the internet, which will convert a byte array to a hex and all that. Then look at the code. Okay, what am I doing over here? I'm having a mapper. What will be the input to the file? This is what is the file name, and this is what is the byte array, right? So now I am going to get the byte array for a particular file. So see over here, I'm passing on the value that is a byte writable and passing it on to the calculate MD5, and I will get a string. That is a 32-bit string. Exactly, Dheeraj. So you use MD5 for comparison also. Exactly. That is correct, Dheeraj. You got it correct. Okay. So then what do? I put that MD5 32-bit character into a string. And then what do? I give that as the key. And what is the value for that? The value for that is the file name. Okay. So it will be good if you write over here file name so that people will understand it, because key will be confusing. So I'm going to mention it like this. Okay, so text is going to be the file name. The value is going to be the byte array. I convert that byte array, get the MD5 string, and then what do is I will give the MD5 digest, which is a 32-bit number. So what will happen? We will put the file where MD5 is a key, so the duplicates will be grouped together for the reduce function. So what will the shuffler do? All the similar keys will be given to the same reducer, right? Sorry, all the similar values, not keys. All the similar values, okay? That means all the file names which has got the same MD5 will be grouped together. And that is what we are going to see in our reducer. So if you look at our reducer now, you will see here, okay, the key here is MD5 hash, and the values are all the image files that are associated with it. For each MD5, we need to take only the first file because I want to ignore the duplicate, right? So what do? I will put it into a for loop, okay, take up whatever is the file path, and then I will say break. Okay, I'm interested only in the first one. And then what will I print out? I'll print out what is in the result file. The key will again be the image file name. Okay, so the image path is what will be there. So you will get whatever is the final output that will be coming down is the path of the image. Okay. So the actual file path is what will be shown to you. And if you are not interested in this key, the key is going to be the MD5. So you could have simply said image file path, and then you could have also said double quotes, double quotes. If you're not interested in showing to the user what is the hash. If you're interested in showing the hash, you can do that also. Okay. So this is the way how you will do the complete example. Let me go back. So Manish was asking, why are we having duplicate at the reducer level? Can't be done at the mapper level? No. The reason it can't be done at the mapper level is because supposing if you have got a lot of files, people have used this algorithm to find out duplicate files in their repository. I have got more than, let's say, 25,000, 30,000 files. Okay, images, and I wanted to find out the duplicates. So it might get into multiple blocks, right? So if I wanted to do it across all the blocks, I have to do it at the reducer level only. I can't do it at the mapper level, Manish. Make sense? Good. So now let me quickly go down to the driver code. So in the driver code, you will see what is the input format class that am I using? I'm using sequence file input format class. What is the reducer class am I using? Duplicate reducer, and this is the mapper class. And then what is the output key class, value class, and then how you are doing the complete job.wait for completion. Okay? So this is the way how you will actually be doing the driver code. Okay, cool. So what did we see? We saw how to use our sequence file with an image. So guys, you would really will have to try all of these examples with the actual way of working with it, guys. Otherwise, it would not be easy for you. So please try out all of these examples. So seventh file, let me do a word wrap. This is what we had seen till now. So let me go back to the presentation. Let me go to the next slide. So please, like I have been reiterating, practice this advanced MapReduce code that is there in your LMS.